So this video is going to show you how to solve solution stoichiometry problems. So with solution stoichiometry, it's similar to gas laws where we're going to combine the dimensional analysis problems with an idea. These ones specifically, we're using the molarity equation. So there's two ways you can do this. You can either use the molarity as a conversion factor, or you can use the molarity formula right here, m equals moles over liters, and use that to solve for moles. And that's what relates to stoichiometry, to get us between solution amounts and then figuring out usually a mass. So with these ones, in AL, it looks like they're always starting with aqueous solutions. So we're only going to be finding grams. So I'll show you that example. There are ones where you could start with grams and then figure out how much of a solution you'd need to measure out, so you could solve for liters. But we're just going to do this one problem, and pretty much all but one of the AL problems, which will step you through it, is going to follow the same pattern. So the first method is where we're going to use the molarity as a conversion factor. So with this, if we look at our molarity is moles over liters. So this number could be rewritten as 0.200 moles of AgNO3 in 1 liter of solution. So this becomes a conversion factor, and we're actually going to start with the 0.2 liters. Now, one thing to note about this is that usually when we have a conversion between moles and something else in stoichiometry, the moles is 1. So this does trip people up. That's why I'm going to show you the other version. Just remember that the number goes with moles and the 1 goes with liters with this. So with this one, this is going to be our starting value, the 0.2 liters, which would be 200 milliliters. In both cases, that is going to be the starting value, the liters. Well, kind of. Okay, and that's for AgNO3. And we're going to use this as our conversion factor. So 1 liter we're going to cancel out, and 2 moles of AgNO3 will go on top. All right, and then from there, it becomes a stoichiometry problem where we're going to find grams of AgCl. So actually, everything from this point on is going to look the same for both methods. So now that we have moles of AgNO3, we can use our balanced reaction to switch substances. So AgNO3, there's a 2 in the equation, and we're switching to AgCl, so that's going to be 2 as well. And then I didn't cross anything out. Final step is to convert to grams. So AgCl, we would add up the molar mass, or just look it up online. That's going to be 143. Nope, that's a 32 grams. Okay, so as a reminder, the new part here is this, using the molarity as a conversion factor, because we know that molarity is moles over liters, so we can turn that into a fraction like this. When we solve the problem, multiply everything on the top, divide by the stuff on the bottom. We have 3 sig figs as our starting value. But for some reason I rounded it to 2, so I don't remember what it is. something after there. Put a 0 for now. Okay, so that's method number 1, using the molarity as a conversion factor. The other way you can do it is you can use this equation, the molarity equation that we did for concentration, to figure out moles of whatever solution you have, and then do the stoichiometry for the last part. So plugging in the numbers from the equation here for molarity and volume, we're going to plug it into this equation and solve for moles. So symbol for moles is N, so that's what I'm going to use as my variable. So the molarity was 0.200 molar, given right there, that's M, is equal to moles, which again is abbreviated N in chemistry, over liters, which is 0.200 again. And then when you solve that one, you get N equals 0.0400 moles. And that's of AgNO3, because that's what we had in the problem. And this becomes the starting value for the stoichiometry. So what you would do is you take this number, the moles of AgNO3 that we found from the molarity equation, that's moles of the solute, and from now on, it looks like what we had here. That part matches. So once we have moles of AgNO3, the stoichiometry lets us switch substances. So again, moles of AgNO3 go on the bottom. From the equation, that's 2 moles of AgCl on top. This should look similar to what we did in gas laws. And then same thing, we're switching back to grams. Struggle. And you get the same answer. And as a reminder, I don't know why I rounded that to 2 sig figs, but it should be 3. Yeah, so either method will work, either using the equation to find moles, then plugging moles in as your starting value for the stoichiometry, or using the molarity as your conversion factor and starting with liters. Pick the one that makes more sense for you, because that will be more successful. All right, best of luck.